Hi everyone, and welcome to the fourth and final video going through some past exam questions on bonding and structure. The first question here, what is the name of the term used to describe repeating patterns in the periodic table? That is called periodicity. A nice little 1 mark question. Okay, melting points show a trend across a period. Here are melting points of 3 elements. Explain the trend in terms of the bonding and the structure. Now we've seen a similar question to this in one of the previous videos, and again it's about making sure that we've done exactly what it's asked us to do. Okay, it wants us to talk about it in terms of bonding and in terms of structure. So we're going to do that for each of these 3 things. We're basically going to say the bonding in aluminium is, the structure in aluminium is, the bonding in silicon is, the structure in silicon is, and so on, and just make it super clear. Okay, so let's say aluminium is a metal. So aluminium has a giant metallic lattice structure. So that's the structure. It has metallic bonding. So there's the bonding. And then let's just describe what metallic bonding is, which is a strong electrostatic attraction between positive ions and delocalized electrons. Okay, what about silicon? Silicon, this is one that we just need to learn really, although you can tell from the melting point. Look how high its melting point is compared to the others. This must be a giant lattice structure. Okay, there's no way a simple molecule could have a melting point as high as that. And silicon's a non-metal, so it must be a giant covalent lattice. Okay, it's good if you can learn that, but it's kind of obvious from the melting point. It must be a giant lattice structure. Okay, so silicon has a giant covalent lattice. And then in terms of bonding, held together by strong covalent bonds. Let's mention the particles as well, by strong covalent bonds between silicon atoms. One of the other questions that was similar to this said, you know, name the forces and name the particles, didn't it? It doesn't say that here, but let's just do it anyway. Okay, and then finally phosphorus. Okay, we can use the same kind of logic here. Look, phosphorus has a very low melting point. So it's the opposite logic to silicon. It definitely isn't a giant covalent structure. This must be a simple molecule, and that's why its melting point is so low. So phosphorus has a simple molecular structure with weak London forces. Must be London forces, right? Because it's just an element, so there's no permanent dipoles, so hydrogen bonds, obviously. So it's a simple molecular structure with weak London forces between the molecules. Okay, so we've talked about the bonding and the structure. Now we just need to link it back to the melting point. So here, in a similar way we did with the other question like this in a previous video, we're just going to rank these now in order. Okay, so we can say the covalent bonds in silicon are the strongest force, followed by the metallic bonding in aluminium, the London forces in phosphorus are the weakest force and require the least energy to overcome. So talking about the energy there is the bit that then links it in with the melting points. If it takes less energy, it's going to have a lower melting point. You're not going to have to heat it up as much. Okay, final question that I want to have a look at is this one here. And this is essentially a GCSE question. Be nice if this one came up. It's basically asking us about the properties of graphite, and it wants us to describe the bonding and the structure and explain the properties that it talks about here. Okay, so hopefully we know this from GCSE. Graphite is a giant covalent structure. Let's say giant covalent lattice structure. It has layers of carbon atoms with only weak forces between the layers. This means the layers can slide over each other, which is why it's soft. Okay, and then I wanted to talk about the melting point next, because this often confuses people, because you're saying, well, if it's got weak forces, how come it's got such a high melting point? Okay, well, it's got weak forces between the layers, but the covalent bonds within each layer are very strong. And if we want to melt graphite, we need to break both those forces. We need to break the weak forces between the layers, and we need to break the covalent bonds within the layers. Okay, so that's why it ends up with such a high melting point. Okay, graphite has a high melting point because the covalent bonds within the layers are strong and require a lot of energy to break. Okay, right, finally we need to talk about why graphite is a good conductor. Okay, so graphite is a good conductor of electricity because each carbon atom bonds to 3 others and has 1 delocalized electron. The delocalized electrons can move through the structure and carry charge. Okay, so there we've explained everything. Okay, we've talked about the bonding. We said it's got covalent bonding. We talked about the structure. It's a giant lattice and it's in layers. It's a good conductor because it has delocalized electrons. It's soft because the layers can slide over each other because there's only weak forces between them. And it's got a high melting point because although it's got those weak forces, it also has very strong covalent bonds that take a lot of energy to break.